We've now come to the point that we have to ask the question, well, what happens when I have a really complex circuit? How would I be able to analyze it and understand what is happening in that circuit? So here's a circuit. It's really complicated because no one resistor is in series or parallel with the other. R1 and R3 are not in parallel because we have R5 and R6 that are connected to them. And R2 and R4 are not in parallel configuration because we have R5 and R8. And R7 is not in parallel with R3 and R4 because we got R5 there. There's nothing that we can simplify in this circuit to be able to do any kind of analysis to understand what currents are flowing or what we can do with it. Well, we can solve this though by using Kirchhoff's rules. And there's two of them. There's Kirchhoff's, some people pronounce it Kirchhoff's. I've always heard it Kirchhoff's, so that's fine. Either way, Kirchhoff's or Kirchhoff's, it's however you want to say it. Kirchhoff's voltage law. And it basically says that the sum of all the potentials in a loop is equal to 0. Or we can say that the sum of all the voltage increases is equal to the sum of all the voltage drops. Well, what do we mean when we say this? And we say it's in a loop, right? That this applies in a loop. Well, what are we defining as a loop? Well, that is a good question. There are multiple loops in this circuit. There's this loop here, and basically all it is basically starting at some point and getting back all the way to the beginning. There's one loop. There are so many loops in this circuit, I don't know whether I can even find them all. There's, of course, the whole outer loop. There's another one. And there's the inner loops. So there's this one. And there's this one. And we have another. Do you see any others? Oh, there's a lot more. Because anywhere I can do a stop point and a start point makes a loop. So I can have this as a loop. Or I can have this as a loop. And I've got another one here. I have this as a loop. So you begin to get the idea. There's a lot of loops in this circuit. A lot of things that we can use. And Kirchhoff's has to apply to every single loop that we're finding here. That the sum of all the potentials have to be equal to 0. Let's see, I got some others here. We've got So we've done that whole loop. So we can do in here. There's another loop. And got a couple more. Can do this loop. And we've got this loop. And I think that's pretty much it. So you notice there's a lot of loops here that we can use. Okay, now let's get rid of this, now that we understand loops. And we'll talk about Kirchhoff's other important law. Okay, get all of my scribble marks off here. Okay, so now we have Kirchhoff's, get back to black pen. We have Kirchhoff's current law. And these were for loops. This is for nodes. Nodes are common connections. And here he says that the sum of all the currents has to be equal to 0, or we can say that the sum of the currents entering is equal to the sum of the currents exiting. So we have a number of nodes here. It's a connection with three or more devices. Actually, you could say two, but three makes it more sense. So we have this node, and this node, and this node, and here's one, and we've got 6 nodes in this circuit. And so what Kirchhoff is saying is that if I have a current that flows in this direction, then there has to be currents flowing in or out. In this case, I'm going to think it's going to be flowing out. And the sum of those three have to equal 0. There can't be any other currents coming in to this node other than the 3. And if I have this current here, it's most likely going to flow this way. So the sum here has to equal 0. Here I have flowing in, we'd say that's positive, flowing out is negative. And at this point, I would have this coming down, maybe current going away, current going this way. So there's 3, 1 in, 2 out. Here I'm going to have interesting because this current's flowing from left to right. It's going to be flowing in here, and I'm going to have 2 currents flowing in, but only 1 current flowing out. So the Kirchhoffs will help us at the nodes to be able to understand what currents are flowing, and we can use these two relationships, Kirchhoff's voltage laws, Kirchhoff's current laws, and use Ohm's law to solve probably 99% of the circuits that we have.